This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you. It was the study of matter that led the Greeks to search for the fundamental elements that made up all of the stuff around them, creating the concepts of elements and atoms. Aristotle then set out to organize what was previously examined and presently available to him, creating not only categories to classify all the stuff, but also specific sciences which study branches of knowledge by applying a methodology of thought, which prevents contradiction, called logic. To be specific, Aristotle said, this is what we have available to us. 1. Substances. 2. Quantities. 3. Qualities. 4. Relations. 5. Wheres. 6. Whens. 7. Relative positions. 8. States of being. 9. Action. 10. Affection, having been acted on. The substances are composed of 4 elements: fire, earth, air, and water. To be said to be a substance requires taking on a Platonic form, or a Platonic geometry, as we will call it. Aristotle called this concept Heil. Aristotle called this concept Heil, and it can be said to be the principle of how an object receives definiteness. Aristotle stated, by Heil I mean that in which itself is neither a particular thing, nor of a certain quantity, nor assigned to any other of the categories by which is being determined. Heil can be thought of as a type of quantum field, which is a plenum throughout space, and when it interacts with something, a form, or a geometry, a shape, a symmetry, then, and only then, does it become something, namely that which it is determined to be by the geometry of the stuff it is attached to. Matter, then, to Aristotle, is that out of which stuff is made. The quantum Heil combines W parts of fire elements, and X parts of earth elements, and Y parts of air elements, and Z parts of water elements, in order to create a matter visible to us. A superposition of classical elements creates a particular matter with a particular attribute which are associated to those elements. In the category list of 10 types of things, matter is a type of relation, such that its existence depends on the elements that make it up, and the relationships between those elements, and further, that its entire existence after its formation is also relational to other objects and subjects in reality. For example, earth and water are the substances that make up clay. Clay is the matter substance of those elements, and those substances are the matter of that substance. Clay is the matter of a brick, as a brick is made of clay. A brick is the matter of a brick house, as a brick house is made of brick. The houses are a matter of the city, etc. Therefore, you can see how logic is being formed by Aristotle, as one can use this information to grasp that a brick house is made of clay by the transitive property. From all of this, Aristotle creates the science of physics, the study of nature, which to Aristotle includes the study of mind, sense experience, memory, biology, and anatomy. But the general nature of the study, which allows it to cover such a broad range of topics, is that its purpose is to strictly study change. You can think about it like this. Aristotle believes that he has a way of knowing how or why an object is the way it is, and knows what it is going to do or be a part of, given the four types of causes. And so all that is left to Aristotle to be concerned about is the describing, documenting, categorizing, classifying, and, possibly, finding rules which govern the physical patterns for objects that we see on a day-to-day basis. For example, the physics of a brick house, in the sense that he can say that the brick house has matter, which are bricks, which are clay, which are 5 parts earth, 1 part water. Then that the material cause of the brick house was those elements, that the formal cause was the Platonic geometry of house shape. The effective cause was the builders building the house for the new statesman. The final cause was so that the new statesmen of the city would have a place to live, as to better the world, which increases the good of the universe, which brings us closer to being like the prime mover. What was then more of a concern for Aristotle was what would happen if you threw that brick. What happens if you slide that brick? What happens if you drop that brick? When you displace it from its natural habitat, how does it respond? When the matter is acting as he would expect given natural causes, he calls that natural motion. And when you slide or toss a brick, when it is acting apart from its natural causes or motions, he called that unnatural motion. And of these types of physics, there is a division of static versus dynamic. Static physics being when the acceleration is 0, and dynamics being when acceleration is not 0. When the Western world stepped out of the scholasticism and into the scientific revolution, they picked up where Aristotle left off, but questioning if what he said was true, and calling it natural philosophy. One of the concerns was that Aristotle said we are higher matter forms. On a matter-form sphere, in the center of a universe, surrounded by concentric spheres of celestial, unchanging, pure form ether. But now we know that there are comets and moons that revolve around other planets, and that stars can explode, and that we spin and move around the sun. What appears to be the sun moving flatly across the inside dome of a celestial sphere is actually a supergiant massive light and heat thing which disappears at night because we are rotating on the surface of a sphere. The geometry of how we must think about reality is different from the geometry of the universe presented to our eyeballs. Aristotle also said that objects will fall at different rates, given the matter that makes them up. But Galileo showed that they fell at the same rate, except in the case where air resistance affects the objects. But if that object was massive enough, it would overcome the air resistance and would fall at a rate of about 9.8 meters per second squared. How objects moved, and how objects fall, and how objects float, thus became of great interest, and so too did the other objects that were discovered when Aristotle was found to be wrong, like what is the sun, such that we move around it? Why is it hot and bright? What are the stars? Are they just other suns? If they're other suns, do they have planets? Do those planets have life on them? Why did one of them explode? Is ours going to explode? When? Will it hurt? What are comets? And why do they move funny compared to the other planets? Why do objects orbit each other? Why do they fall? Why do they push each other when they bump into each other? Isaac Newton did his best to answer as many of these questions as he could. He studied light by blackening out his lab, and then letting in only a pinhole of light. And he found that a glass triangular prism would scatter the light beam into a rainbow of color, which he could then put through another prism and make white light come back out. Or he could block a color and make a different color of light appear. Newton thus proved another Aristotle knowledge nugget wrong, as Aristotle thought white light was the more fundamental than the colored light. As for matter, Newton found a way to generalize the principle of motion of matter, whether that was in the celestial motion or locomotion on Earth. The way he was able to generalize them was with discovering 3 principles of motion and force. 1. Objects naturally resist change to motion, and, therefore, objects in motion remain in motion at a constant speed and in a straight line, and objects at rest remain at rest. 2. It is forever the case that the rate at which an object's momentum is changing over time is equal to the net force on that object. 3. If 2 objects exert forces on each other, these forces have the same magnitude but opposite direction. Motion then depends on the amount of matter contained in the object, as well as the speed and direction of the object. If that motion changes, it changes in time, which can be described by forces. Since most of the time mass does not change over time, it becomes more simple to say that force is equal to the object's mass times its acceleration, or its velocity changing in time, or its position changing over time in a certain non-linear manner. Given these laws, Newton was able to generally predict the future events of planets, comets, the moon, the tides, and the motion of objects tossed by humans, whether by machine or hand. The mechanics of calculus are invented and required to understand change. And one such happy consequence that pops out of all of this is the law of the conservation of momentum. Momentum is conserved over space for its form of motion. One other such change that Newton sought to understand was the change of temperature between objects. Newton's law of cooling is a physical law that states that the rate of heat loss of an object is directly proportional to the difference in the temperature between the object and the environment. This means that a hot object in a cold room, or that a cold object in a hot room, will eventually balance out to be the same warm temperature. Newton's spectra of colored light and his laws of motion and his laws of cooling slowly over time get intertwined, as it turns out that motion and temperature are related, and so too is temperature and color of light. But before we get there, let's take one step back. This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you.